Hi everyone, I would like you to make sure that you have a different colored pen. I'm going to have you correct it using a video because I want you to be completely engaged and in tune to what you're doing wrong so you can do better on tomorrow's common assessment. So we're going to be going over this take-home assessment a step at a time. Alright, for the first problems, you have to perform the transformation. So perform means you're actually drawing the shape, not just coming up with your new ordered pairs. But it's always nice to start with the ordered pairs. So A is 1, 0, B is 5, 4, and C is 1, 4. So that is really important, and I believe that the triangles for all of these types of problems are the same. So you have all of your first ordered pairs. And then you have to look at what the transformation is. This says we're going 2 to the left and 5 down. So we can do this a couple different ways. I can actually move each point 2 to the left, 2 to the left and 5 down. So 2 to the left and then 5 down. Or I can change my ordered pairs. So some of you might choose to do it this way. So 2 to the left and 5 down, 1, 2, 3, 4, 5. And don't forget prime notation, A prime. Or 2 to the left means you're subtracting 2, 5 down means you're subtracting 5. From subtracting 2 from each of your x's and subtracting 5 from each of your y's. So 1 minus 2 is a negative 1, 0 minus 5 is a negative 5. So we just drew in that point at negative 1, negative 5. So it doesn't matter whichever way you feel more comfortable. So B prime would be 3, 4 minus 5 is a negative 1. So I could go 1, 2, 3, negative 1, and that is my B prime. Or I could have moved 2 places to the left and 5 down, and I would have ended up at the same spot. And then C is negative 1, negative 1. So negative 1 right there. And remember, if you come up with a shape that is not congruent, in other words, it does not look exactly like your original shape with if you are translating, rotating, or reflecting, then you know you're doing something wrong. All right, for this one, this is where many of you, or if you were not using your coordinate notation, you messed these up. Reflecting over the x-axis, if I look at the notes, the coordinate notation says over the x-axis, the x stays the same and the y becomes the opposite. So the x stays the same, y becomes the opposite. X stays the same, y becomes the opposite. X stays the same, y becomes the opposite. For a reflection over the x-axis. So through magic of television, I have already plotted those points for you, so you can see I just plotted these points. The other way you can do this, if you so choose, is if B is, since it's a reflection over the x, and remember this is the x, if B was 4 above, the B prime needed to be 4 below. So that's another way you could do this. You could actually reflect it first and then get your ordered pairs. All right, for the next one, I've been very upfront with you. I use the coordinate notation every time with rotations. So I see that it is going to be a 90 degrees counterclockwise. So I go to my notes. I see 90 degrees counterclockwise. The coordinate notation is we flip them, and the first becomes its opposite. So that's what I'm going to do. I'm going to go down here to my ordered pairs, and remember they were the same. So they were 1, 0, 5, 4, and 1, 4. And I'm going to follow that rule. So I'm going to flip them. So my new A prime is 0, 1, and I change the first one to its opposite, but there's not an opposite 0. The second one, it is 4, 5, but the first one has to change to its opposite. And the second one, I'm flipping them, and the first one has to change to its opposite. So now I can plot those points. 0, 1 is going to be right there. I'm going to make this a little bit bigger so we can see. So 0, 1 is right here, and it is A prime. Don't forget to label. -4, 5 for B. So -1, 2, 3, 4, and then 1, 2, 3, 4, 5. That's going to be our B prime. And C was -4, 1, 2, 3, 4, and 1. And that's C prime. And when I connect them, even though it's a different orientation, the triangle should still look the same. So again, I use the coordinate notation every time. So for rotations, I do the coordinates first and then plot them. All right, for the last one, the points changed, and again, magic of television, I already wrote them in, but I want to remind you, dilations, this is where some of you had a difficult time on the formative. For dilations, you're just taking your original x, y, and you are multiplying them by that scale factor to get your new ordered pairs. So my scale factor is 1/4. Remember, multiplying by 1/4 is the same thing as dividing by 4. We have to talk about it as a factor because it's a scale factor, but in your head, if you want to divide by 4, that's fine. 4 divided by 4 is 1, 0 divided by 4 is 0. 8 divided by 4 is 2, 4 divided by 4 is 1. And 4 divided by 4 is 1, 1. So here are my new points. So then I can plot. I'm going to maybe make this a little bigger so you can see. It is going to be a very small, because it is 1/4 of the size of that original. Okay, so hopefully you will be able to use your coordinate notation and your notes to get the new ordered pairs for each of these types, because this is what you have to do to be able to get a 1. Alright, for this next one, you can do this a couple different ways. Some of you can visually see. You can see, okay, C is, let me get to the pointer. For this one, for example, C is the same distance away from the Y on one side as on the other side, and same with B and A. So some of you can see that is a reflection over the x-axis. So the transformation, reflection, and yes, you have to use correct vocabulary, over, I think I said x, y-axis. So the rule, x, y, the rule is if it's over the y-axis, the y stays the same, but the x becomes the opposite. So it would be that. Some of you won't be able to do that. This is where I suggest you write the ordered pairs. For example, A is, the original A is 1, 2, 3, 4, -4, -2. My new A is 4, -2. So what's happening? So from our x, y, what we're doing, the order stays the same, x, y, but the x becomes its opposite. And then you have to look on your charts to see which rule this follows. So some of you can see the transformation and then write the rule. Some of you have to write the rule given the ordered pairs and then work backwards to get the transformation. Okay, so for example, here if I write one of my ordered pairs, I'll start with B. So that's -2, 3. My B prime is to -3. So our original xy, we didn't change the order, we just changed the sign. So if I look at my coordinate notation and I scan to see which one fits this, the transformation is rotation 180 degrees about the origin. We don't need the direction because it's 180 degrees. And this is what you would have for your rule, xy. Please, I hope you're correcting and making changes and making this beautiful. Okay, perfect. Okay, so to me these are the easiest because I can see that I'm just sliding each of the points down. So I'm just sliding each of the points to a new location. So if that's the case, it's a transformation. Sorry, it's a translation. And you just have to figure out how much you're moving. And it's important you notice which one is the original. So this is the original. So what did we have to do to A to get to our new A? I'm going to start with the X. We had to go over, I'm going to do this in blue. We had to go over 1, 2, 3, 4, 5, 6 to the right. So we had to add 6. And we had to go down 1, 2, 3, 4, 5. So we added 5. And I'm going to just check to make sure I counted right. For my C, 1, 2, 3, 4, 5. I have to draw this, I guess. 1, 2, 3, 4, 5, 6, and down 1, 2, 3, 4, 5. So I know that this is correct. So I always check a separate point. All right, the last 3 transformations left congruent shapes. They were exactly the same shape and size. Where I can see this one is not the same size. It is a similar shape. So I know my transformation is going to be a dilation. That's the only one that changes the size. Dilation. Now, you can look at ordered pairs and remember this is the original, so it's getting bigger. So I'm going to be multiplying it by a bigger number. So I tend to look at sides. CB was 3. C prime, B prime was 1, 2, 3, 4, 5, 6. So I know that my new shape is twice as big. So that means my scale factor was 2. So the rule, I started with my xy, and I had to multiply my x by 2 and my y by 2. All right, hang in there, we're almost done. This is what you have to do to get a 3. You have to be able to, without graphing, determine the transformations. And for me, this is the easiest because of that list that I gave you. So I look at each one. So let me make this bigger for us. I look at each ordered pair and I see what's happening. So I always start with my rule. So what is happening to my original? So here I see they flip every time. I see they flip, and the y, this new one, stays the same. So the x stays the same, but the new x, so the one in this position, becomes its opposite. So this is my rule, And if I look at my chart, that matches up with 90 degrees counterclockwise about the origin. Oh, and I forgot the word rotation. And just to show you where I got that from, so this is what you have in your notes. I wrote this first because they flipped places. The first one became the opposite. So it's 90 degrees counterclockwise about the origin. Or you could have written 270 clockwise about the origin. So it's rotation. You needed the direction, the direction, the degrees about the origin, and that it was rotation. All right, next one. What I am seeing here is that the x stays the same and the y becomes the opposite. So I write the rule first. The x is staying the same and the y is becoming the opposite. The one, and I have this one memorized, and it's true with all of them, the one that where the x stays the same is where we are reflecting over the x-axis. X stays the same, it reflects over the x-axis. All right, this one, C. At first, when I look at it, it seems like the x or the y's are switching places, but it doesn't match up with my x's. So now I'm wondering if I'm adding or subtracting. I'm wondering if it's a translation. So from 5 to 6 is plus 1. Does that match all of my x's? 3 to 4 plus 1, 6 to 7 plus 1, 8 to 9 plus 1. So now I'm thinking that this is a translation because it looks like I'm adding something or subtracting something. For my y's, 6 to 4 is minus 2, 2 to 0 minus 2. So that works out. So my rule, I start with my original, and I take the x and I add 1, and I take the y and I subtract 2 to get my new ordered pairs. And lastly, so we've done a reflection, we've done a translation, we've done a rotation. So the last one that I'm thinking we're going to do is possibly a dilation. And if I look, all of my numbers are significantly smaller. And is there a common factor? That's what I'm going to be looking for, if they're significantly bigger or smaller. So negative 5 to negative 1, negative 15 to negative 3, negative 10 to negative 2. All of them, it's like you're dividing by 5. Dividing by 5 for all of them. But we have to talk about the rule in terms of our scale factor, multiplying. So I know that this is going to be a dilation. And instead of dividing by 5, remember, it's keep, change, flip. It's multiplying by 1/5. So the dilation with scale factor of 1/5, and my rule, I start with my original, and I notice I'm always putting that rule in terms of the original first, and then what did I have to do to the x? I multiplied it by 1/5. What did I have to do to the y? I multiplied it by 1/5. I suggest that you watch this part and practice this part before the common assessment. Okay. The last one. To me, this is the easiest 4-level question ever, as long as you remember that it's a sequence. So you're starting with here and you're doing 3 different things to it. First, dilate scale factor of 1/2. Okay, to me, this is the absolute easiest 4-level question ever, as long as you remember it's a sequence. So we're doing a sequence of events. So you're starting with here and changing it, and changing it again. So the first one is easy. As long as you remember, when you dilate, you multiply. Factor means multiply by 1/2. So you're taking 1/2. So 1/2 of 4 is 2, 1/2 of 10 is 5. So that's all you're doing to get your new ordered pairs. Easy, easy. So we're done with that transformation. The next, 90 degrees counterclockwise about the origin. So remember, I look at my rules for this one. If I can get these rules to, I guess I can't, but I can see them. I know that my rule is for this one, X, Y, I am flipping, and the first one becomes its opposite. So I flip and make the first one the opposite. I flip and I make the first one the opposite. And I know that because we explored and came up with this rule, that that's what we were doing. I flip and I put the first one as the opposite. So now I have this one done. And lastly, reflect over the y-axis. This one I don't have to look at. This one I have memorized. If I'm reflecting over the y stays the same and the x becomes the opposite. And again, we know this rule because we played around with it on the coordinate plane and we saw that's what was happening with the ordered pairs. So the y stays the same and the x becomes the opposite. So now, if I started with this, I could do this sequence using coordinate notation, and I could have a new shape at the end. Please look at the rubric and give yourself a score now. So question 1 was the 1 level, question 2 was the 2 level, question 3 was the 3 level, question 4 was the 4 level. Yes, go ahead and do 0.5s if you got part of it correct. And let's see where you're at. Hand this in and then start your 10 marks assignment.